Awesome. Hi, everybody. We will now be recording question 2 in the Winter 22 final exam. All right. Okay, so this question is about branch prediction. It says, consider the following LC2K program running on our 5-stage pipeline path from lecture. This program counts the number of zeros in the binary array and stores that in R5. Okay, I'm going to kind of skip over the program right now. I'm going to see what it's asking me. So it says, write the sequence of branch decisions for each BEQ instruction using T to represent taken and N to represent not taken. So we can break this down. I think I'm going to work through it, going like one by one in terms of the branch instructions. So looking at the line 4 BEQ, what is this line BEQ doing? So this is the main loop. And what it's going to do, this branch instruction iterates every time that we check if we are bigger than the length size, right? So our array is 3 large. And so that means on the first iteration, our register, our counter register, I don't even need to read the program to know what it is going to start at 1. And then it's going to go to start at 0, and it's going to go to 1, and then it's going to go to 2, and then it's going to go to 3. And at 3, I'm going to jump to the end of my program, right? And so it only performs, this branch is only taken if I is equal to length. So it's only taken on the last one. And so the behavior that we might expect to see is not taken, not taken, not taken, taken. Moving on to the 6, the instruction at line 6, we have a branch which is checking if the array at that index is equal to 1. So the first question is, how many times is this going to iterate, or how many times are we going to execute this instruction? Well, we're going to execute this instruction for every time that this first one is not taken. So we're going to run it 3 times, right? 1 for each thing in the array. So the first time we do have a 1, and so we're going to take it. The second time we do have a 1, so we're going to take it again. And the last time we don't, so we're not going to take it. So that's the second, that's the line 6 BEQ. And then looking at the line 9 BEQ, well, the first question is, how many times are we going to execute it? Well, we're going to execute this instruction every time, once again, that we iterate. So we're going to have it execute 3 times. And because it has the same registers for the equality check, we're going to take it every time. Take it. Okay. So then it says give us the combined sequence as seen globally. So just we need to consider kind of the ordering of everything. So the first instruction we're going to run across is the line 4 BEQ, which is a not. So essentially, we're just going down and then sideways. So we're going to get not. We're going to not taken. Then we're going to taken. Then we start at the top again. Not taken, 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 not taken, not taken, taken, and taken. Awesome. So that's part A. That's just kind of working through the question. Part B says, what percentage of the total branch decisions are correctly predicted when using the following prediction schemes? So essentially, we're just going to walk through our schemes and consider how many times we'd get hits and how many times we'd get misses given the schemes. So if we predict always not taken, we can just look at the combined sequence. And essentially, we just need to look at how often the branches are taken and how often they're not taken. So we have a total of 10 accesses. So we're going to divide by 10. And the number of times that they're not taken is 1, 2, 3, 4. So 4 out of 10 times, we are going to correctly predict it. Looking at the second one, we have predict backwards taken and forwards not taken. So essentially, it's dependent on the which branch instruction that we're looking at. So line 9, its offset is going to be negative because it's doing a backward branch. So this is going to always predict taken. And for the other 2 ones, because they're forward branches, we're going to predict not taken. And then so we can just kind of evaluate how well we're doing. For the first one with this scheme, we're going to go 3 for 4, right? Because there's 3 not takens. Then we're going to go 1 for 3 on the second BQ. And on this last one, we're going to go 3 for 3. So then we can sum them up. Remember, not as fractions, but as kind of like the numerators and denominators. And what we get is 3 plus 1 plus 3, which is 7. And then there's still 10 Flash accesses. Okay. So then it says predict using a local 2-bit branch predictor to initialize to the starting state strongly taken. Okay. So basically, we're just going to walk through each BQ again. So if we're initialized to strongly taken, then we're going to predict strongly taken here, and we're going to get it wrong. Then we're going to, because we got it wrong, we're going to move to weakly taken, and we're going to get it wrong again. So then we're going to predict to weakly not taken, and we're going to get correct. So we're going to move to strongly not taken, and then we're going to get incorrect. And so our final results here are going to be, well, we got it wrong the first time, wrong the second time, correct the third time, and wrong the last time. So we're going to go 1 for 4 here. Then looking at this, we're going to go strongly taken because we got it correct, strongly taken again because we got it correct, and then the last one we'll get it incorrect. We'll go 2 for 3. And then on this last one, we're going to go strongly taken the entire way through. We can go 3 for 3. And so the total is we're going to go 1 plus 2 plus 3, which is 6 divided by 10. So we're going to have 6 for 10. Okay, that's the entirety of question 2. This is not intended to be a question that takes a ton of time, just evaluates your understanding of different predictor configurations and instruction access patterns. Any questions? I'll give it a couple seconds, and if not, I shall end this recording. Awesome.